Now here's a quick video about what I think we might at best call a few odds and ends. So these are these things I talked about. Some of the other kinds of patterns. Um, so one was macros. So macros are used a lot in C programming. Macros are a form of textual substitution. We can use them for clever things. I had a small example that you can find in the source code of how to do an internal domain-specific language for the state machine using in C programming or using C macros, because you can do clever things with and concatenate names and surprising amount of complexity actually. So the CPU processor is something that runs whenever you compile a program in C. So if you could take a C program, you run it automatically through the C preprocessor. It gives you a different C program that's then compiled. You can actually use the C preprocessor on anything. So you can take a Java program, which is what I did to do a small internal DSL, run it through the C preprocessor, and then get something else. There are actually other macro preprocessors out there that are more suitable for this kind of thing. So that was more of a demonstration than what you really want. So um, what the important thing to keep in mind is that macros can sometimes have surprising effects. So suppose we do a macro for maximum, the maximum of x and y we define like this. If x is greater than y, then x, otherwise y, using the ternary question mark colon operator. This doesn't work if you do something like max of 5 and I++. This then becomes 5 is greater than I++. If yes, then x, otherwise I++. So we run the risk that I is incremented twice, which you might not expect, probably wouldn't expect it. And in general, you have to be careful. So now here we put parentheses around it. If not, then the 5 would be multiplied directly onto the 7 and it wouldn't work either. So many things can go wrong with macros. Be careful. The notification pattern is about how to collect errors when you're passing. Read about it. It's a good thing to keep in mind, but not something we work so much with. So some of the really important patterns are like the semantic model, which obviously we talked a lot about. Symbol table that basically we collect names of things as we're going along and build a table mapping from names to objects. We use that both for internal DSLs and for external DSLs. Context variable is that we have a variable that tells us what are we currently working with, what are we currently building. So this is one of the things that lets us chain together long sequences of things in a way such that it looks like a language, but it's really just a bunch of separate expressions that are building something because they happen to be evaluated one after the other. The construction builder is about if you have an immutable object but would like to build it a bit at a time, normally you can't because you have to provide all values to the constructor. So what you can do is to use an intermediate object where you collect all information and then instantiate the object and you're fine. I also sometimes talk a little bit about Lisp. So the interesting thing about Lisp is that the syntax is so simple. So here we have a small function. So functions are defined with defun foo function taking a value x. Then we say if, and now this is all operators are prefixed. So if plus 13 times 7 is greater than x, then that's actually an error here. That's strange because this means calling a function. So I don't know why I have the function 28 and yes here. We could put a small quotation mark in front, then it would be a value instead, which is the nice thing. So suppose we had a small quotation mark here. Oh, I can maybe even go and make one. The ranges are here. A quote. Here we go. So quote means build this as a value. So what was before a function call to the function 28, which doesn't really make sense, with the argument yes, now becomes build it a list of data with 28 and yes. And here we call in the function list to build a list with the value no and x. So what's interesting here is that with inserting just one character, we changed something that was a bunch of code calling a function to some data. And I also put a small, I think there's a small quote sitting up here, which means that rather than computing this, then we just return the whole thing as a value and could then give it to someone else to evaluate. So program generation and program evaluation is very close to each other here, which is very interesting. Another thing that's interesting from the point of view of domain-specific languages is that what's here in the middle here with entity system, entity person, name string, and so on, is perfectly normal legal Lisp syntax. I mean, we can't tell the syntax for the built-in stuff is the same as the syntax for DSLs. So DSLs are natural in Lisp, which is nice because we like DSLs. So I won't talk so much more about Lisp. There might be a bit more, but not too much. We also had a short talk about models and meta models. So here the squiggly arrow means meta. So we've seen some examples of the entity system. So we might have a university system or business system, and they're defined by this model where you have so the university system, for example, has a person with teacher and student and so on. And then when we meta this, we have entity type that have entity fields, and we call this an entity relationship system. So that's the meta of the university and business, all of these systems. What is the meta of that? What is the meta of our entity relationship system, of our GUI DSL, of our state machine DSL? Well, we can use UML to express all of them. So UML is a common meta model for all of our meta models. What is then the meta model for UML? Because you can know meta, you can keep going. What is the meta of whatever? Well, the meta model for UML is actually the UML meta model, which is well defined. You can look it up. It's interesting. And if you modify the UML meta model, you modify UML. So if you want to add things to UML, if you want to add your own kind of thing to UML, you do it by extending UML meta model, which is nice. UML is by design, as of UML 2. Whatever, extensible. And if you have a tool that fully supports UML 2. Whatever or up, then in fact you should be able to add your own things to the tool. They won't magically have new graphical representations, but boxes and lines that before meant one thing can now mean something else. What is then the meta model of the UML meta model? Well, it is cleverly defined in terms of itself. This is a computer science thing, and it's a bit weird, but it's sort of okay. And this concludes my odds and ends. Thanks for listening.